Before getting into our final equations, I want you to realize that these equations are a tool, but not a prison. You still have to think. Thinking is your most powerful tool in physics. So you will rarely find one equation and one step that solves problems. You have to keep an open mind and try many. Now, a new problem. What can we do if we don't have any data on time or time elapsed of a motion? We know it's constant acceleration, but we have nothing on time, no t. No time elapsed, no time interval. I'm serious, nothing. Nothing on time. So we might know the acceleration, the initial velocity, information like that.
Again, we're going to start with the first motion equation. V final equals V initial plus acceleration times time. And the second motion equation, that the displacement is the actual true average between the final and the initial velocity times the time, because this is the average velocity. Okay? We are now going to take a look at trying to get rid of our time. And so what we can do here is solve the first motion equation for time. V final, subtracting V initial from both sides and dividing by the acceleration is the other name for the time. What we can do now is substitute that into our second motion equation for time. So that's what I'm going to do. I'm going to start with the second motion equation. Now I have D is equal to 1/2 V final plus V initial, and then I'm going to multiply that by the other name for time, which is V final minus V initial over A. V final minus V initial all over A. Okay? This is actually a pretty simple algebraic transformation, so let's take a look and see if you can follow it. I'm going to basically put in the denominator this 2 and the A. Okay? And then I'm going to have, with my D over on the left standing for displacement, I'm going to have V final plus V initial in parentheses times V final minus V initial in parentheses. This is, you should understand, FOIL, right? First outer inner last. First outer inner last is going to give me our final result, which will be that the displacement is, now when you have a difference of squares like this, you have V final plus V initial times V final minus V initial. It's a difference of squares, and that is going to cancel out the outside and inside. So my first term is going to be V final squared. My outside term is going to be negative VI VF, and my inside term is going to be positive VI VF, so that's going to go away. And my final term is going to be a negative VI squared. Okay? V final squared minus V initial squared. Okay? And then what we're basically going to do is keep in mind that this is going to be over 2A. And what I can do then is focus on solving for V final squared. So if I want to keep the V final squared alone, I'm going to write it like this. V final squared is not moving, but what I'm going to do is I'm going to multiply both sides by 2A to get rid of the denominator. So that gives me V final squared on the right and 2AD on the left, and then I'm going to add to both sides VI squared. And so we have the fourth motion equation, and of course the reflexive property allows us to go either side of the equal side. So we're going to have that the V final squared is equal to V initial squared plus 2 times the acceleration times the displacement. Okay?
So there you have it, our fourth equation, which is the square of the final velocity, Vf squared, is going to be equal to the square of the initial velocity, whatever the velocity of the motion was to begin with, plus 2 times the average acceleration times the displacement. Remember, displacement is your final position minus your initial. So I know you're starting this because you've got the solution, right? You're doing this the right way. If not, you're really not going to get much out of this video tonight. And the neat thing of this, we finally have our fourth motion equation because we don't know anything about the time. We know the distance. By now we should know the acceleration is going to be minus 9.80 meters per second squared. And with a little imagination and setting up a coordinate system, we actually do know our VI. But this time I decided to take a different approach, just to show as long as you're consistent in your coordinate system, you'll get the right answer. I decided to set the ground at 0 meters. So therefore, if I'm 5.3 meters up in the air, and up is positive, my DI is plus 5.3. So let's follow that coordinate system, plug it in. Okay, I know at the beginning I'm holding the ball, it's not moving, that's why I'm 0. As we scroll to the right, my displacement is very important. I take my df, which is 0, minus my di. So I have a displacement of minus 5.3 meters, because remember, it's heading down. So I have 2 times my acceleration, negative 9.80 meters per second squared, times my displacement, negative 5.3 meters. So simplify those last two. I have 2 times 51.94 meters squared per second squared. But to get VF, I'm going to have to do the square root. So VF equals 103.88 meters squared per second squared. And when I'm done and it goes significant digits, it's going to be either plus or minus 10 meters per second. Why did I erase the plus? Because it's downward. I know it's minus 10 meters per second.
Clouds move